So let's do a couple of problems in which we have to find a function with a given differential. So the first one is find a function such that df is the following. 2xy minus 3z squared dx plus x squared minus 4yz dy plus minus 2y squared minus 6xz dz. So let's see, solution of this problem. So all those problems are very similar. The solutions are pretty automatic. So differential is partial derivative with respect to x dx, partial derivative with respect to y dy, partial derivative with respect to z dz. And therefore we can say df over dx equals to 2xy minus 3z squared, df over dy equals to x squared minus 4yz, and df over dz equals to minus 2y squared minus 6xz. So now we know the derivatives of f. F is a not yet known function with respect to x, y, and z. How to find the function f? We have three versions to find the function f. In this version, the function f is the antiderivative with respect to x of the first item written here. So this one implies f is integral of 2xy minus 3z squared dx plus a constant, but if we speak about the integral with respect to x or differential with respect to x, then the other two variables are treated as a constant, so plus a constant c of y and z. So therefore, f will be x squared y minus 3xz squared plus c of y and z. Okay, so this is what we derive from the first relation. So from this one, we derive this one. From the second one, in a very similar way, we can derive, we have to integrate x squared minus 4yz with respect to y. So f will be x squared y minus 2y squared z plus another constant, but now the constant depends on x and z. So we have to call it a different name, plus d of x and z. And finally, from the third relation, so we are looking at f from three different angles. So looking at f from three different angles, we get a sort of a puzzle, which will provide us the exact formula for f. So from this angle, we have to find f by integrating the third relation with respect to z. So f will be minus 2y squared z minus 3x z squared plus a constant e of x and y. So these three relations are like a puzzle. So one single object f, we are looking at it from three angles of view. So now we have to unify those three pieces of information to find a unique function f, modular constant, which is of this form and of this form and of this form as well. So let's try to put together a piece of the puzzle. So we got an x squared y which appears in both sides. So x squared y, we just put it as a unified piece, minus 2y squared z appears in two places. minus 2y squared z, and then finally minus 3xz squared. And now plus, so there is no more, the constant here generating constant, so plus c. So these are all the functions on smooth functions on in three variables satisfying df is given by this formula. This is the answer to your problem. Okay, so let's do another one. Okay, so let's see. I got this for with maple, so I have to keep in mind that. So we want df equals to 3x squared y squared, 3x squared y squared plus 5y z squared dx plus 2x cubed y 2x cubed y plus 4y cubed z z plus 5x z squared dy plus y the power 4 plus 10x yz dz. So we have to figure out all smooth functions with the property that differential of f is equals to this differential form. So again, as before, so df over dx should be 3x squared y squared plus 5yz squared. df over dy must be 2x cubed y plus 4y cubed z plus 5xz squared. That's it. And df over dz equals to y the power 4 plus 10xyz. So let's see which conclusion can we derive from each of those three. For the first one, we integrate with respect to x. So what do we get? Integrate with respect to x. So we get f will be x cubed y squared plus 5xyz squared plus 5xyz squared plus a constant c of y and z. Second, we integrate with respect to y. So f will be x cubed y squared from the first one plus y the power 4z from the second one plus 5xyz squared plus a constant which depends on x and z plus d of x and z. Finally, a third look on f from a different angle. So f will be, we integrate with respect to z, right? Y the power 4z plus 5xyz squared plus a constant p of x and y. So we got again the same triple loop on f from different angles, from the angle of x, angle y, and angle z. What will be this object f? So we have to unify those three formulas. So if you look at these three and try to find the unitary formula for f, look at the common pieces of the puzzle. X cubed y squared appears in two places. So f will be x cubed y squared plus 5xyz squared plus, which appears in three places, plus y to the power 4z. We accounted for all of them now. Now plus a constant c, which is genuine constant. So if we look at this formula, after a little bit of inspection, this is of each one of these three types. So this would be the all smooth functions on R cubed, satisfying partial derivative with respect to this coefficient, partial respect to y is this one, and partial respect to z is this one. So that's the answer to the problem.